Welcome to Module 2, Ethical Frameworks and Moral Philosophy in Artificial Intelligence. In the previous stage of the course, the concern was what it means to approach artificial intelligence responsibly, and why technical performance alone is never enough when intelligent systems begin shaping human decisions. This module moves the conversation into the deeper moral foundations that help us judge whether an AI system is being used well, fairly, and with regard for human dignity. Artificial intelligence does not make ethical questions disappear by making decisions faster or more data-driven. Often, it makes those questions more visible because the consequences of design choices can be scaled across large populations. As we begin, the purpose is not to treat ethics as an abstract add-on to computing, but to understand ethical reasoning as part of the intellectual structure that should guide AI development and deployment. When we speak about moral philosophy in the context of AI, we are asking how human beings ought to reason about choices that affect other people. That question becomes especially important when automated systems influence access to jobs, education, healthcare, credit, public services, or legal outcomes. A model may appear neutral because it operates through mathematics, data, and code, but the goals it is optimized for, the data it learns from, and the ways its outputs are used all reflect human priorities. Ethical frameworks give us language for examining those priorities rather than assuming that efficiency, accuracy, or profit automatically tells us what should be done. In this module, we will use those frameworks to slow down the decision-making process just enough to ask what values are being served, who may benefit, who may be harmed, and who remains accountable when an AI system contributes to an outcome. One reason this work matters is that AI often operates in situations where reasonable people can disagree about what the most responsible choice should be. A system designed for public safety, for example, may raise questions about fairness, surveillance, privacy, and unequal treatment, even if its designers claim that it improves prediction. A system used in hiring may help process applications quickly, yet still reproduce patterns of exclusion if past employment data already reflects biased opportunities. These are not simply technical defects that can always be repaired by adding more data or tuning a model. They are moral problems because they require judgment about competing values, about the distribution of risks and benefits, and about the responsibilities of organizations that place automated tools into social environments. This is where ethical theories become useful. Utilitarian thinking asks us to consider consequences and overall well-being, which can be powerful when AI systems affect many people at once. Deontological ethics reminds us that people should not be treated merely as instruments for achieving organizational goals, even when a system produces efficient or statistically useful results. Virtue ethics shifts attention toward the character, habits, and practical wisdom of the people and institutions designing these systems, asking whether their decisions reflect responsibility, humility, justice, and care. None of these frameworks gives us an automatic answer for every AI dilemma, but each one helps us notice something important that another framework might leave in the background. The value of comparing ethical frameworks is that AI problems rarely have only one morally relevant dimension. A decision may improve aggregate outcomes, while still placing an unfair burden on a particular group, or it may respect formal rules while failing to show adequate concern for the people most affected. When we examine a system from more than one ethical perspective, we are less likely to accept a narrow justification simply because it sounds technical or efficient. This broader reasoning matters because responsible AI requires the ability to connect philosophical principles to governance, design, evaluation, and institutional practice. As we move through the module, the goal is to become more precise in how we evaluate AI-driven decisions. Ethical analysis is not about memorizing philosophical labels. It is about developing disciplined ways of reasoning when technology affects human welfare. A responsible AI practitioner should be able to recognize when a system raises questions about fairness, when it creates accountability gaps, when it treats individuals too narrowly as data points, and when its benefits are being measured without adequate attention to its harms. That kind of reasoning requires both conceptual depth and practical judgment. By grounding our discussion in moral philosophy, we can approach artificial intelligence not only as a technical achievement, but as a set of human choices that must be examined, justified, and governed with care. In this slide, we begin with the first learning objective for the module, which is to explain major ethical theories relevant to AI decision-making, including utilitarianism, deontology, and virtue ethics. That wording matters because ethical analysis in artificial intelligence is not only about identifying whether a system is technically effective. It is about asking how decisions should be judged when they affect people's opportunities, rights, welfare, and treatment within social institutions. Moral philosophy gives us a foundation for that kind of judgment because it offers structured ways to reason about what makes an action, policy, or system morally defensible. Without that foundation, organizations can easily reduce responsible AI to compliance language or public relations statements, rather than a serious evaluation of how automated systems shape human lives. Utilitarianism is often the most familiar starting point because it focuses on consequences and asks whether an action produces the greatest overall benefit or the least overall harm. In AI decision making, this framework can be attractive because AI systems are frequently justified through claims about efficiency, scale, prediction, and improved outcomes across large populations. A healthcare model, for example, might be defended if it helps more patients receive timely diagnoses, or a fraud detection system might be defended if it protects many people from financial loss. But utilitarian reasoning also requires careful attention to who receives the benefits and who absorbs the costs. If an AI system improves average performance while consistently disadvantaging a smaller or less powerful group, then the appeal to overall benefit becomes ethically incomplete. Deontological ethics approaches the question from a different direction by emphasizing duties, rights, principles, and respect for persons. From this perspective, an AI system cannot be judged only by whether it produces a useful outcome. We also have to ask whether the system treats individuals fairly, whether it respects their autonomy, whether it allows meaningful contestation, and whether it avoids using people merely as data points for institutional goals. This framework is especially important in high-stakes AI because automated decisions can affect people who may never understand how a judgment was produced or how to challenge it. Deontological reasoning reminds us that a person's dignity does not disappear just because a decision has been translated into a model output. Virtue ethics gives us a third lens by shifting attention toward character, judgment, and the habits of the people and organizations building AI systems. Instead of asking only what outcome is produced or which rule is followed, virtue ethics asks what kind of decision maker is being revealed through the design and deployment of the technology. Are the developers, managers, and institutions acting with prudence, fairness, honesty, humility, and responsibility? Or are they rushing a system into use because it is profitable, impressive, or convenient? This framework is valuable because responsible AI depends on more than written principles. It depends on professional cultures capable of recognizing uncertainty, listening to affected communities, and exercising practical wisdom when technical options carry moral risk. Each of these frameworks gives us a different way to examine the moral consequences of AI systems. Utilitarianism directs attention toward aggregate welfare and the balance of benefits and harms. Deontology directs attention toward duties, rights, and principled limits on what organizations may do, even in pursuit of useful goals. Virtue ethics directs attention toward the moral character and judgment of the people and institutions responsible for the system. When these theories are placed side by side, they help us avoid a narrow ethical analysis in which one value, such as accuracy or efficiency, dominates every other concern. This is why ethical theories are useful for decision makers working with artificial intelligence. They do not remove complexity, and they do not provide automatic answers that can be applied mechanically to every case. Instead, they discipline our reasoning by helping us ask better questions about fairness, responsibility, and human well-being. A responsible decision maker should be able to recognize that an AI system may look successful under one framework while still raising serious concerns under another. Learning these theories, then, is not a philosophical detour from AI practice. It is part of the work of evaluating whether intelligent systems are being designed and used in ways that can be morally justified, especially when their outputs influence real people rather than abstract cases. This foundation prepares us to compare those frameworks more carefully as the module develops. This slide moves us from naming ethical theories to comparing how those theories influence the evaluation of AI-driven outcomes. That comparison matters because the same AI system can look more or less acceptable depending on the moral framework being used to judge it. A model may be accurate, but ethical evaluation asks a broader question. What kind of outcome is being produced? For whom? Under what conditions? And with what consequences for people and communities? When organizations evaluate AI only through technical metrics, they may overlook the moral assumptions built into those metrics. Ethical frameworks help make those assumptions visible, so evaluation becomes more than a narrow calculation of performance. From a utilitarian perspective, the evaluation of an AI-driven outcome tends to focus on overall consequences. Decision makers ask whether the system increases well-being, reduces harm, improves access, or produces better results for the greatest number of people. This can be useful when AI systems operate at scale because small changes in accuracy can affect thousands of people. Yet this framework also pushes us to be careful about distribution. If an algorithm improves the average outcome while placing heavier burdens on a vulnerable group, the language of overall benefit may hide a serious ethical problem. Utilitarian evaluation therefore requires asking not only whether the system works, but how benefits and harms are distributed across the affected population. A deontological framework changes the evaluation by placing duties, rights, and principles at the center of the analysis. Under this view, an AI-driven outcome may be morally troubling, even if it produces useful aggregate results. If people are denied an opportunity without explanation, if they cannot contest an automated decision, or if the system relies on data gathered without meaningful consent, the outcome raises questions that efficiency alone cannot answer. Deontological reasoning asks whether individuals are being treated with respect, and whether the organization has honored its obligations to fairness, transparency, due process, and human dignity. This framework reminds us that some limits should remain in place even when crossing them might produce operational advantages. Virtue ethics influences evaluation in a different way because it asks what kind of judgment and institutional character are reflected in the system's use. A technically sophisticated AI tool may still reveal poor ethical judgment if it is deployed carelessly, if leaders ignore foreseeable risks, or if an organization treats affected people as obstacles rather than stakeholders. From this perspective, evaluation involves looking at the habits, values, and practical wisdom behind the decision-making process. Did the organization act with humility about the limits of the model? These questions matter because AI outcomes are produced by technology operating inside human institutions. When we compare these frameworks, we begin to see why ethical evaluation can produce different emphases. Utilitarianism may direct attention toward social benefit, deontology toward rights and obligations, and virtue ethics toward the quality of judgment behind development and deployment. None of these perspectives should be treated as the only legitimate form of evaluation. Instead, they work together by revealing different dimensions of moral concern. A system that appears justified because it improves average outcomes may still fail if it violates basic rights. A system built by well-intentioned people may still require revision if its real-world outcomes create inequity. This comparative approach is especially important because AI-driven outcomes affect individuals and communities at the same time. A decision about one person's loan, diagnosis, job application, or risk score may seem isolated, but when similar decisions are repeated across a population, patterns begin to emerge. Those patterns can shape community-level opportunities, reinforce existing inequalities, or change how institutions allocate resources. Ethical evaluation therefore has to move between the individual and the collective. It has to ask whether the system treats particular people fairly while also asking whether its broader pattern of outcomes supports responsibility and human well-being. By comparing ethical frameworks, decision makers become better equipped to analyze fairness, responsibility, and human well-being with depth rather than relying on a single moral vocabulary. This does not mean that every framework will always agree or that every dilemma will have a simple resolution. A responsible organization must explain how it weighed competing values, why it accepted certain trade-offs, and how it will monitor the effects of those choices over time. That is the value of comparison in ethical AI. It forces evaluation to become reflective and accountable rather than automatic. This slide asks us to analyze ethical dilemmas that arise when AI systems impact human welfare and societal equity. That language signals an important shift in the module because we are no longer talking only about ethical theories as abstract frameworks. We are now applying those frameworks to situations where automated systems influence the conditions of people's lives. Human welfare refers to more than convenience or efficiency. It includes opportunity, fair treatment, safety, dignity, and meaningful participation in society. Societal equity asks whether those opportunities and protections are distributed fairly across communities, especially when institutions already operate within histories of unequal access and unequal power. The slide identifies several areas where AI systems may have serious consequences: hiring, medical diagnoses, criminal justice decisions, and financial access. These are not minor administrative settings. They are domains where decisions can shape employment, health, freedom, security, and long-term economic stability. When AI is introduced into these settings, the system does not process information in a neutral vacuum. It becomes part of a social process that may already contain bias, pressure, inequality, and institutional habits. This is why ethical analysis has to examine not only the model itself, but also the environment in which the model is trained, deployed, interpreted, and acted upon. Medical diagnosis raises a different but equally serious set of concerns. AI systems can support clinical decision making by identifying patterns that human practitioners might miss. But those systems may also perform unevenly across populations if the training data underrepresents certain groups. In healthcare, the consequence of uneven performance can be profound because a false negative delayed diagnosis or inappropriate recommendation can affect a person's well-being directly. Ethical reasoning therefore has to ask whether the system is reliable for the full range of patients it will serve, and how responsibility is shared when an automated recommendation influences care. Criminal justice and financial access make the issue of societal equity even more visible. Risk assessment tools, predictive systems, and automated scoring models can appear objective because they use formal calculations, but the inputs may reflect patterns shaped by policing practices, neighborhood inequality, income disparities, or unequal access to credit. In these contexts, an AI system can transform historical conditions into future constraints if its outputs are treated as neutral facts. A person may be labeled high risk, denied a loan, or offered worse terms because the system has learned from a social world that was never evenly structured. The dilemma is that the model may be statistically coherent while still participating in an ethically troubling pattern. This is why the slide emphasizes that outcomes can influence human welfare at both individual and community levels. At the individual level, a person may lose an opportunity, receive an incorrect assessment, or face a decision they cannot understand or challenge. At the community level, repeated automated decisions can shape patterns of exclusion, resource allocation, surveillance, or institutional trust. A single decision may look small when viewed in isolation, but AI systems often operate repeatedly and at scale. Ethical analysis has to recognize how repeated outputs can accumulate into social effects that are larger than any one case. Unintended consequences are especially important because harm does not always come from malicious intent. A team may build an AI system with a legitimate goal and still produce unfair outcomes if the data are incomplete, social context is ignored, or accountability is unclear. Historical inequalities can enter through training data. Incomplete data can make some groups less visible, and unclear accountability structures can leave affected people without a meaningful path for correction. These are ethical dilemmas because they involve responsibility under conditions of uncertainty. The appropriate response is not to assume that automation is harmless, but to ask careful questions before, during, and after deployment. To analyze these dilemmas well, we need to connect technical evaluation with moral reasoning. Accuracy, precision, and efficient matter, but they do not exhaust the ethical responsibilities involved when AI systems affect welfare and equity. We have to ask who is represented in the data, who is missing, who benefits from the system, who carries the risk, and who has the authority to contest or revise an outcome. That kind of analysis helps prevent responsible AI from becoming a slogan. It turns ethical reflection into a disciplined practice for examining how algorithmic outcomes affect people, communities, and the social institutions that shape their lives. This slide focuses on the role of ethical reasoning in guiding responsible technology development. Responsible development is important because it reminds us that AI systems are not simply released into the world after technical testing is complete. They are designed, trained, evaluated, deployed, monitored, and governed through human choices. At each stage, decision makers define the problem, choose the data, decide what counts as success, and determine acceptable risks. Ethical reasoning gives structure to those choices by requiring organizations to ask whether their decisions can be justified in relation to fairness, responsibility, and human well-being. In practical terms, ethical reasoning connects the design of an AI system to the lives of the people who may be affected by it. A development team might begin with a technical goal, such as improving prediction, reducing workload, or identifying patterns more quickly. Those goals may be reasonable, but they are incomplete unless the organization also asks what the system will do to people's opportunities, privacy, autonomy, and ability to challenge decisions. A responsible design process requires more than asking whether the model performs well on a benchmark. It requires asking whether the system is appropriate for the setting, whether the data reflect the population being served, and whether the intended use respects the people involved. This is why organizations must consider ethical theories when designing and deploying AI systems. Utilitarian reasoning can help leaders examine whether the system is likely to produce meaningful benefits and reduce harm at scale. Deontological reasoning can help them identify duties that should not be ignored, such as the duty to treat individuals fairly, explain consequential decisions, and avoid using people merely as inputs for institutional efficiency. Virtue ethics can help organizations reflect on the quality of their own judgment, including whether they are acting with honesty, humility, prudence, and care. When these frameworks are brought into development, they help turn ethical responsibility into analysis, rather than a vague statement of good intentions. Ethical reasoning also plays an important role in governance. Governance refers to the policies, procedures, oversight mechanisms, and accountability structures that guide how intelligent technologies are used. A responsible organization does not assume that an AI system remains ethical simply because it was approved at launch. Conditions change, data drift, users adapt, and harms may become visible only after deployment. Ethical governance requires attention to monitoring, auditing, feedback, and revision. It also requires clarity about who is responsible when the system produces harmful outcomes, because responsibility cannot disappear behind technological complexity. This slide also emphasizes that responsible technology development requires reflection on fairness, responsibility, and human well-being. Fairness asks whether the system treats people and groups in ways that can be justified, especially when outcomes affect access to opportunities or resources. Responsibility asks who makes decisions, who oversees the system, who has the authority to intervene, and who answers for consequences. Human well-being asks whether the system supports or undermines the conditions people need to live with dignity, security, and meaningful agency. These questions are connected because an AI system may be efficient while still being unfair, or legally permitted while still failing to support human welfare. Automated decision-making creates difficult questions because it often distributes action across many people and technical components. One team collects data, another trains the model, another integrates it into a platform, and another uses the output in a real decision. When responsibility is spread across this chain, ethical reasoning helps prevent organizations from treating harm as nobody's fault. It requires attention to the full decision process, not only the final prediction. It also requires asking whether humans retain meaningful oversight or whether they have become passive reviewers of automated recommendations that they rarely question. The deeper purpose of ethical reasoning, then, is to connect AI decision-making with responsible deployment. A system should not be judged only by whether it can produce an output, but by whether its use can be defended in the setting where that output matters. This means that ethical analysis has to be part of planning, design, testing, implementation, and governance. It helps organizations recognize trade-offs, explain choices, and revise systems when evidence shows that people are being harmed or treated unfairly. In this way, Moral reasoning becomes a practical discipline for building intelligent technologies that are powerful and accountable to the human purposes they are supposed to serve. This final slide asks us to assess the limitations of applying traditional moral philosophy to complex AI systems. That is an important closing move for the module because ethical theories are useful, but they were not originally designed for technologies that learn from massive data sets, operate at scale, and influence decisions across complicated institutions. These theories give us powerful ways to reason about consequences, duties, rights, character, and judgment. Still, AI systems raise practical and conceptual challenges that can make those theories difficult to apply cleanly. Responsible ethical analysis therefore requires respect for traditional philosophy and a clear understanding of the complexity introduced by modern automated systems. One limitation is that AI systems operate inside social environments already shaped by history, policy, economics, and unequal access to resources. A moral theory may help us ask what should be done, but the system may be trained on data that reflects what has already happened under unequal conditions. If past hiring, lending, policing, or medical access patterns were unfair, then the data used by an AI system may carry those patterns forward, even when no one intends to discriminate. Traditional moral philosophy can tell us that fairness matters, but it does not automatically tell us how to repair a data set that reflects institutional inequality. The ethical problem is embedded not only in the algorithm, but in the social world from which the algorithm learns. Another limitation appears when data are incomplete or unevenly representative. Many ethical frameworks assume that decision makers can identify relevant facts and then reason from those facts toward a judgment. In AI practice, however, the facts may be partial, noisy, outdated, or missing for the communities most affected by the system. This creates a difficult situation for ethical reasoning because the moral question cannot be separated from the quality of the evidence. If the data are incomplete, ethical evaluation must include uncertainty, humility, and a willingness to question whether automation is appropriate. Accountability is another major limitation when traditional moral philosophy is applied to complex AI systems. In many ethical theories, responsibility is often discussed in relation to agents who make choices, understand reasons, and can be praised, blamed, corrected, or held accountable. AI systems complicate that picture because outcomes may emerge from a chain of decisions involving data collectors, developers, vendors, managers, users, and institutional policies. When harm occurs, each participant may claim that they controlled only one part of the process. The result can be an accountability gap, where the system affects high-stakes decisions, but no single person or organization clearly accepts responsibility for the outcome. This problem becomes more serious when automated systems are used in areas such as healthcare, criminal justice, education, employment, or finance. In these settings, people may experience the consequences of a decision without being able to see how the decision was made or who had the authority to change it. A person denied an opportunity may be told that the system generated a score, but that explanation does not necessarily provide accountability. Traditional moral philosophy helps us insist that responsibility matters, but complex AI systems require governance structures that translate that principle into review, documentation, appeal, audit, and correction. Without those structures, ethical language remains disconnected from institutional practice. The slide also reminds us that even well-designed technologies may produce unintended consequences. This point is crucial because ethical failure is not always the result of reckless behavior or obviously bad intentions. A system can be carefully engineered and still behave differently when it encounters new populations, changing conditions, or unexpected patterns of use. Users may overtrust recommendations, managers may rely on outputs too heavily, or institutions may scale a tool beyond the context in which it was tested. Traditional moral theories can help identify the values at stake, but they do not remove the need for ongoing monitoring after deployment. Assessing these limitations does not mean abandoning moral philosophy. It means applying it with care and realism. Ethical theories give us essential questions about welfare, rights, duties, justice, character, and responsibility. But AI systems require those questions to be joined with empirical evaluation, governance, stakeholder input, and continual oversight. The responsible approach is not to force every AI dilemma into a single philosophical formula. It is to use moral reasoning as a disciplined guide while recognizing that automated systems operate in environments filled with uncertainty, inequality, and institutional complexity.